Here we are again, part 2 for you. All right, where do we go? And the answer is A, point A. All right, if you did point A.
That was a question. Sorry.
G3.
Oh, yeah.
Oh my gosh! I'm getting somewhere.
Jonathan's getting
I
somewhere. Yay. All right, we're going to part A, and in order to find, let's say that this thing is starting out still, what equation will I apply at A to find total energy? So again, we're still talking theory. It's starting out still. What equation will I use in this problem to find total energy? We already assumed it's going to be at point A. But what equation will I use to find total energy? You have your response?
Yes.
All right. It turns out to find total energy when the object is still, you'll recall, when it's still, there's no kinetic energy. So the only equation that you need is potential energy. mgh will get you total energy at point A. So if you were able to do that, and you'll actually do that with numbers in a minute, so now you'll know what to do. N2. If you said mgh, that's all you need to find the total energy, because there is no kinetic at that point. All right, let's change this. Let's change this, and we'll say it has a velocity this time. When it reached point A, the car or cart had a velocity, but now it's going to cut off its velocity and glide the rest of the way. But it's going to have initial velocity. It is not still. So it has a v sub o. So how now, brown cow, do you find the total energy at point A? It will no longer be mgh. So what will, it will no longer be mgh only. So where do you go, what formula now will you use to find total energy in this system when the cart has an initial velocity? What equation will you use for TE now? So it's the same question, but now the cart is moving. What equation will you use for total energy now? We already established it's going to be at point A, but what will be the equation? Responses in? All right, the equation for total energy at point A, now that it's moving, total energy will equal potential plus kinetic. So here it is, mgh plus 1/2 mv squared. That is the correct response. Hopefully somebody got it, and we'll do N3.
Yes. One away.
I'm one away.
Don't tell me what it is, or I will not call it. All right. Some more theory about this. All right, we're going to take a cart. It's going to have a velocity at the beginning. And this, again, this cart has a velocity at the peak, but then it's removed and it just glides from there. And I want to know, again, the initial velocity stops right at the peak, and then it glides with the energy that it has to start with. Yes or no? Is there enough energy in this system to reach the top of B? Yes or no? Is there enough energy in this system to reach point B, the way I've drawn it? Can it get up to B? Is there enough energy to get up to B? The answer is no. Nay, nay, nay. Because right here, the total energy is calculated at A. So it will never be enough to get up any higher than it started at point A. So the answer we will do, or the response, 03. We'll come back to this theory and actually do a problem or two in a minute. Let's finish some other theory first. All right, I'm mowing the lawn, and when I mow the lawn, one day I'm feeling kind of bad, so I mow the lawn. It took me 2 hours. Tomorrow I'm feeling much better, and it grew back overnight. I'm going to mow it again, and I'm only going to. It's going to take me 1 hour to mow the lawn. What quantity has changed here? So I mow the lawn in 2 hours, then I mow it in 1 hour. What quantity has changed here? I'm looking at a concept that we learned, the very last thing in this mod. What is the difference between mowing the lawn in 1 hour or mowing the same lawn in 2 hours? It's a measure of what quantity that changes.
Can you give the first letter?
I'll give you the last letter.
Okay.
R.
Okay.
Okay.
Good. What? Wait.
I got
I
you.
had an idea, but then I was like, R, what?
The last letter in the word is
I don't
R.
even know any
Can
words
you-
that end with. Oh, never mind. Like, if you mow the lawn in 2 hours and then you mow it in 1 hour, what quantity has changed? I thought it was a different one.
Is it just one word or is it?
No, in one
It's
word.
one word and it ends in the letter R.
No, you're going to send the pencil through. It's your word.
I don't know what.
Alright, so when I am mowing the lawn, and the first time I do it in 1 hour, second time in 2 hours, or vice versa, I have changed one thing in this scenario. And the important thing is that you don't use the word work, because work doesn't end in R. But I did the same amount of work, no matter how fast I did it. The thing that changed was power.
Oh my
That's
gosh.
superpowers.
Remember, power is work divided by time. Work is force times distance, and time is what power involves time. Work does not. So if you said power,
I3.
Come on, come on.
G2,
I hate
G2.
Is that
Okay.
Friction always robs kinetic energy. What form does it take? When friction is a force, it robs kinetic energy. What form of energy does it take? One more time. Friction
Like what?
robs kinetic energy from a system. What form of energy does it always take? Friction always takes the same form of energy.
Like what friction is like as its energy?
Yeah.
Okay.
confused.
Great.
Okay.
What form of energy does friction always cause to appear, always become? What form of energy does friction
Oh.
become? Friction What form of energy does friction become? Always. And it's a robber. It's never the good guy, unless you're trying to slow down. Like if you're falling down the hill, you want some friction. But it's always robbing kinetic energy in the form of heat. Heat. Heat energy. Friction always.
Oh, like. It's just like you rub your hands together.
I
there's a
three.
ton of friction.
No.
I3.
Wait, what happened? Is that
You were getting
so excited. I was so excited.
That's the
and
one
then
I
you just
needed.
Did you get the answer? You got it wrong.
No.
Yeah, I did.
Wait, what did you say?
That's the one he needed.
All right, calculators out. We're in.
I was Miss Patty was so close to getting one.
It's against us, too. I just feel
I know, I
like
need
done.
one and 2
All right, I'm gonna pause it real quick and then restart it.
Aaron,
Oh,
10 minutes.
okay.